Good morning, everyone. So now before moving on to the lecture today, I have to remind you some homework assignment due on this week. Okay, so first thing here is the online homework. So maybe you will see it on campus. So this is 4.4, 5.1, and 6.1. Okay, that's in the online statistic homework. So you can see here 4.4 and 5.1, 6.1 due on this Sunday. Okay. And regarding the iterated review should be 5.1 to 6.1. Okay. 5.1 to 6.5. 5.1, 5R1, 6R. And handling homework. Handling homework, we have homework 3. This will due on next Monday, I remember. It's next Monday. Okay, it's due on next Monday. Okay, this homework is due on Sunday, and this homework due on next Monday. Okay. Any question about the homework? This kind of homework is just handling homework is just for chapter 4. This guy chapter 5 and 6. 6 and 6.1, just 6.1. Because in chapter 5 we just cover 5.1. Okay, we don't cover 5.2 to 5.4. Okay, that's in the thing. And yeah, that's all the homework we should focus on. And we will have the exam 2 when we finish chapter 6, and the schedule for the exam 2, the second exam is for this date. Okay, this is a March 4. So I know it's very soon to let you know now, but I will let you know soon to prepare for your exams. And the last time when you did the exam, I saw okay. But
I just wanted to know, for the hand-in homework, are we turning it in class or is it still online?
The handling homework, okay. The handling homework you submit online.
Okay.
Okay. Let me show you. Handling homework here. Okay, let's student view. So when you look at the handling homework here, you will start assignment here, and you upload file here. But remember that you need to submit to me PDF file, just one file, okay? And it's easy for me to grade your homework, okay? Some of you submit to me the file PNG or another file, okay? Sometimes I cannot open it, okay? So it's better if you submit to me only one file and PDF file, okay? That's the thing. Okay. Any questions about this? And the last time when I looked at your first exams, some of you just did it in maybe 30 minutes, but I give you 3 hours to do this. Okay. Okay. Spend your time. Look at your exam very carefully, because it's very crucial and it affects to your GPA. Okay. So I give you a lot of time so that you can do it very well. I think so. Okay, because I don't care about the time, so I give you a lot of time to do this. Okay, try to do it. Okay, and that is the things about this. Okay. Okay, now that's all the announcement I want to let you know. And now we move on to the new section, okay, the new chapter, in chapter 5. In this chapter, we only focus on one section. Okay, this is section 5.1. That is the 4 discrete random variables. What is the random variable here? Okay. And now the objective of this section here, we know the definition of random variables, and we need to know the expected value. What does it mean? And how to calculate the expected value of a probability distribution. And forget about the second goal. We will not cover the second goal here. I forgot to remove it. We only focus on what is the random variable and how to calculate the expected value in this section. Okay, so now I will give you the definition of random variable. Okay, the random variables is a variable whose numeric values is determined by the outcome of probability experiment. Okay, so that's in the definition. Maybe you will see it's very complicated, but it is easy. Okay, so assume that I have the 6. Okay, I have a 6. Okay, I will write down here. Okay, I have the six-sided. I have a six-sided rows. Six-sided. Okay, dice. Okay, and I let x be. Okay, example here. And I let x be the number on the top when I roll a six-sided dice. Okay, x be a number. Okay, x be the number on the top. Okay, on the top. So I roll the dice, so it will be 6, will be 1, will be 2, will be 3, something like that. Okay, and here x is the number on the top, so x is the random variable. X is a random variable, and the values, possible value for x here is 1, 2, 3, 4, 5, 6. Okay, x cannot be 7, something like that. That's called random variable. Or I can say that I can let x be the temperature of something, so x will be the 0 to the infinity. Something is 0 degrees, 70 degrees, something like this. Okay, so now we have two kinds of random variable. The first one is the discrete random variable. In this case, the value you can count it. You can count the discrete random variable. You can count 1, 2, 3, 4, 5, something like this. That's called discrete random variable. Otherwise, it's called continuous random variable. For example, like the temperature. Temperature, you cannot count it, right? Because the temperature will be the number maybe from the infinity. Okay, for example, by the random. The degree may be from 0 degrees Celsius to maybe 17 degrees Celsius. It may be 0.1, 0.2, 0.3, something 0.1, something like that. You cannot count it, right? You cannot count it. In this case, the temperature may be a continuous random variable. Okay, it's different from the discrete random variable. Because the value here may not be counted. Okay, is it clear, guys? Okay, you need to remember, you make the distinction between them. Okay, that is the two kind of random variable. Okay, but in our course, we just focus on the discrete random variable. Okay, because to calculate the expected value of continuous random variable, you need to know the integral. You need to know the material in calculus. So in this course, you will not cover this. Okay. So this will be covered in the higher course called probability and statistics. When you finish calculus 1 and calculus 2 maybe, and you will have the knowledge about the integral. After that, you will learn about the continuous random variable in this course. Okay, not in our course. Okay, so that's the example for random variable. And here, not only x be the random variable, x is also the discrete random variable. Because the value here, 1, 2, 3, 4, 5, 6, we can count, right? And now this is discrete random variable. Okay. Okay. And here we have the definition about the probability distribution. Okay, when we have the random variable, okay, suppose if we use the same example here, so we have the value of x here, okay, x here. Okay, we have 1, 2, 3, 4, 5, 6, okay. That's I used the example last time, okay. 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 For the probability distribution is a table, okay. Is a table like this. The table or a diagram or the formula that give the probabilities for every value of the random variable. Okay, so this is table here. Okay, a table here. Okay, this will contain the value of random variable here. So the value in the first column, you can see that it's a 1, 2, 3, 4, 5, 6 is the value of random variable. It's a value. It's the value of random variable. And here, that's in the probability of the probability for every value, okay? For every value of the random variable. So, for example, probability of x equal 1, that means that the probability we will get the number 1 when we roll a die, six-sided, right? And this row here, that means that the probability when we roll a six-sided and we get 2, okay? And here, that's the probability when we roll a dice and we get the 3, okay? Is it clear? Okay. And now we need to calculate the probability of this one, and this one, something like this. Okay. Could you tell me what is the probabilities when we roll the dice and we get the result 1? Okay, you is read, right?
So,
Okay.
1/6.
Yeah, 1/6, exactly. 1/6. And these guys are also 1/6. Right? Okay, this table will help us to summarize everything about the random variable, right? It will help us to summarize this. And it's called the distribution, probability distribution. And okay, and this it has one property that you need to remember. The first thing, the probability will be from 0 to 1. It's satisfied, right? Because 1/6 is satisfied, is from 0 to 1. And the second one here is the sum of all the probability is 1. Okay, you can see that 1/6, 1/6, 1/6, 1/6, 1/6 plus together, and it's equal 1, right? If you plus together, you give the number greater than 1 or less than 1, so you will, this is not probability distribution. Okay, something like, or you make a mistake somewhere here. Okay, any questions so far? Okay, that is the probability distribution. Okay, so now that's I wrote here, and here we will move on to the next example that is more complicated. Okay, and the question here is create the discrete probability distribution for x. Okay, x means that x is the sum of two rolled dice. X is the sum of two rolled dice. Okay, that means you will roll 2 dice, right? And you make the sum of these. Okay, that is the question. And here you will see that. Okay, that when I roll the dice. Okay, you look at the table here. Okay, when you roll the dice like this, roll 2 dice, you will have this result. Okay, for example, when you roll 2 dice, maybe 1 1, right? Okay, and when you roll is 1 2, 1 3, 1 4, 1 5, 1 6, something like this. Okay, but the x here X is the, okay, the question look at here. X is the sum. X is the sum of two round dice. Okay. So now you look at the experiment here. You look at the result here. So X here is the sum of two round dice. So you write down the X here, right? And the probability of X equals X here. And you know, don't know this is 1. I will write down here. And you can look at here. For example, when I roll the dice, it may be 1, 1. Okay. In this case, the sum of D is 2, right? When it's 1, 1, 2, the sum of D is 3. Okay. So could you tell me the range of the value in this case? The range of the value of random variable X in this case? Okay. I can ask you another side like, what is the minimum value in this case? Okay, you. What's your name?
Sullivan.
Huh?
Sullivan.
Sullivan. Okay. Okay. What's your answer?
2.
2 is the minimum value. And what is maximum value? You please.
Maria, 36.
Okay, Maria's 36. 36.
12.
12, right? Okay. The value here of the sum is 12. Okay. So you can, okay, thank you, Maria. Okay, you can see that. Okay, the number, the sum here is 2, right? It's a minimum value. And the maximum value is 12. Okay, so it will be 2, 3, 4, 5, 6, something like that. Okay, so write down the number here is 2, 3, 4, 5, 6, 7, 8, 10. Okay. Something like that. Okay, so that is the value of the random variable. So this is the first step when you create the discrete probability random variable, discrete probability distribution. Okay. And now, could you tell me what is the probability of the value of the sum is 2? Okay, so you look at the experiment here. Okay, so you will count the case that make the sum is 2. Okay, so when you look at here, you only one case, right? It's only one case. It's E2 2. Okay, that's the sum of E2, right? We will not have any cases. Okay, here is 7, 8. Okay, we only have one case is 2. So here is 1 over. How many possible results in this case? Okay, Robin, right?
Yeah, 36.
Okay, 36. So the probability here 1 over 36. Oh. Is it clear, guys? Okay, it's similar. You do for this. You will count the case that make the sum is 3. Okay, and you get over to 36. Okay, here you have 1, 2, right? Only 2 cases, right? 2, 1 and 1, 2 is 3. Okay, so it's 2 over 36. Okay, is it clear? And about 4, so you look at the table, here is 1, 2, 3. Okay, it's 3 over 36. Okay. About 5, let's see. 1, 2, 3, 4, right? 4 cases, right? 4 cases. Okay. 4 over 36. About 6, you look at here. 1, 2, 3, 4, 5. Okay. Okay, 5 over 36. And 7, you have 1, 2, 3, 4, 5, 6. Okay, 6. Okay, A is different. Okay, A is different. Okay, A here, you see that? 1, 2, 3, 4, 5. You have 5 cases, right? 5 cases. So 5 over 36. And 9, I think it's 4 over 36, 3, 36, 2, 36, 1, 36. Okay, that's the make table. And now we can check. We can check is it correct or not. So you first thing, you see that every number here is from 0 to 1, right? It's greater than 0 and less than 1. So it's okay. The second one, we make the sum of these. If it's equal 1, that's correct. If it's not equal 1, it's not correct. Okay? So you can see that the sum of these should be 1 plus 2 plus 3 plus 4 plus 5. 5, 4, 3, 2, 1 over 36. And you can see the numerator and the denominator is same. So it's 1. Okay? And the table here is correctly. Okay. You can see the table here is correct here. Okay. Any questions so far about this? Okay. Clear, right? Okay. I think I try to make it similar for you to understand. Okay. Okay. So now I will go to the next examples. Okay. Okay. Next example. You will see this kind of problem in the online homework like this. So they ask you construct the discrete probability distribution for the random variable x. Okay, x is the number of tails in for toss of a coin. Okay, you will toss a coin 4 times. Okay, 1, 2, 3, 4. You will toss 4 times. Okay, in this case, you should use tree diagram that I told you before. Okay, I will write down here. Okay, the number of tails, right? The first thing we need to list all the possible results of this experiment. Okay, so the first that I will write down is the fourth stage, right? First stage to the second stage, the third stage, and fourth stage. The first stage it should be the result is x, the head and tail. Only two, right? Only two head and tail. When you toss a coin, and the second stage, you will get two results also. Okay, maybe this is head and tail, right? Okay, and first stage should be head and tail, head and tail, head and tail, head and tail. So this one is head and tail, head and tail, head and tail, head and tail, something like this. Okay, so what is the outcome? Okay, so I wrote the tree diagram for the possible result. So could you tell me what is the outcome in this case? I will give you one outcome for this. Maybe 8. Okay, that is the first outcome. That means that 8 means that four stage you will get all the head, right? All head. Okay. Anybody? I need a volunteer to write all the possible result on the board. Okay. Any volunteer for this? Okay, you please. What's your name, please?
Shreya.
Please, Okay, thank you. Thank you. Okay, so when you look at the three diagram, you can write outcome here. So if you look at here, X here, right? It's on the line. So it's one outcome. And T, okay, is the second one. And T, H here. Okay. So you list all the possible results. Okay, for example, T, H here, that means the first stage you get the head, okay? The second stage you get head, and the third stage you get tail, and the fourth stage you get head. Something like that. Okay? Clear, right? Any question about this? That's it. Just list all possible results. And here, so now you will look at the, you will look at the outcome here. So X here is the number of tails, right? The number of tails. So you can see that when you look at this outcome, the number of tails is 0, right? It don't have any tail here. Okay? And you look at here, what is the number of tails here? Could you tell me what is the number of tails? It's 1, right? It's 1. And look at it, 1. And this is 2 tails, right? Okay, so could you tell me the minimum value and maximum value of the random variable X in this case? Could you tell me the minimum value and maximum value here? Okay, Madeline,
The
please.
minimum is 0 and the maximum is 4.
Exactly, thank you, Madeline. So you can see that you will get the 0 tails, and the maximum you get is 4 tails. So the table for this is, the value here is from 0, 1, 2, 3, 4. Okay, that is the first column. Okay, and the second column is probability. You get the number of tails is 0, the number of 0 is 1, the number of tails is 2, something like that. Okay, and you will calculate the probability for this. For example, the number of tails is 0. It's just okay here, right? Only one is this case. Only all the heads, so this you choose this. And how many outcomes in this case? You will count as this is 16 outcome. 16 outcome. So it's the probability for this is 1/16. Okay. And the second one here is the probability that you will get 1 tail. Okay. So now you look at the outcome here. So you get this guy, okay, this guy, and this guy. Okay, only 4 cases, right? So it's 4/16 here. Okay, is it clear, right? And after that, you will find all the probability here, and you get a table. Okay, and the first, when you finish the table, you will need to check, okay, all the probability here is less than 1 and greater than 0. And the second one here is sum of these is 1. Right? So that is the correct table. Okay, that we finish. Okay. Any question about this? No. Okay, so now we move on to the final content of this section. That's called expected value. Expected value. Okay, the expected values is simply is in the meaning that is in the value in the point in the future, the value that you expect in the future, something like this, that you will expect in a day in the future. That is the expected value. This is something like this, and expected value for the discrete random variables. Okay, and is go to the mean of probability distribution of X. Okay, and okay, you can see that the expected value is calculated for this formula. Okay, sometimes when you look at this formula, you will see it's very complicated, right? So I will give you the example for this. Okay, how to calculate the expected value when you have the probability distribution. You have a table for this. So how to calculate the expected value? Okay, I will give you the example for this. Okay, I will give you to write down the expected value. Okay. So for example, we have the table like this. We have a table like this. It's equal 0, 1, 2, 3, 4. So the probability of x equal x here. So it is 1, 4, 6. Okay. 4, 1. Something like this. So how to calculate the expected value? Calculate this, right? Okay, you can look at okay, don't forget about this. It's just the notation for the expected value. Sometimes you write like the notation like this. Sometimes you write the notation like this. It's new. Okay, it's the same. Okay, but it is better for you to use this notation. So it's the sum of the xi times the probability of xi. Okay, that means that, okay, xi here, right, is x1, x2, x3, x4, x5 here, something like this. And here is the probability of x equal xi. Okay, so the expected value is x1 times this probability. That means you 0 here is x1, right? It's time to the corresponding probability. Here is time to 1 over 16, right? And you plus 1 time to the probabilities, okay? And plus 2 times to this probability, and plus 3 times to this probability, and plus 4 times to this probability. Is it clear, guys? Okay, that's the way to use this formula. Okay, and that we will get the result here by using calculator. Could you tell me what is the value here? Could you tell me the value here? Use calculator. Okay, you don't have. I think I have calculator here. So it's 1. Something like this. So the result should be 2. So that means that you will expect the value 2 when you roll the dice a lot of time. Okay, when you get the expected value 2 here, right? So you can expect that it's easy for you to get the result in 2 in this case. Okay, is it clear, guys? Any questions so far about this? Okay, so now we will move on to the next example. That's a game. Okay, and you can look at the slide. Suppose that Randall and Blake decide to make a friendly wager on the football game they are watching one afternoon. For every kick the kicker makes, okay, Blake will pay to the Randall is $30, and for every kick the kicker misses, okay, the Randall have to pay for Blake, okay, for $40, okay, and okay, and look at the previous game. The kicker had made 18 of his part, 23 kicks this season. And the question here is, what is the expected value of the Randall's bet for one kick? Okay. That is the question. Okay. So now you have 2 cases. Okay, I will put x in the random variable as follow. I will x here is the okay, x here is the money, is the number, the amount of money that the Randall receive. The Randall receive, right? Okay. I will choose x here is the amount of money that Randall will receive. Okay. If he win, he will receive $30, right? If he lost, he will lost $40. So that means that if he win, he will receive 30 degrees, so it's positive. And if he lost, he will lost $40. That means that X here is negative 40. The amount of money of Fredo here is negative 40, right? Because he lost, right? He lost this amount of money. Okay, so in this case, the random. Okay, I'll write down here. Okay. So I will choose X is the amount of money, right? Yeah, okay, okay. So we have two cases. Okay. If he win, he will get 30. Okay. And if he lost, he will get negative 40, right? Because he lost, so it's in negative. Okay. Okay, and see that. As I mentioned, as you can see in the screen, the kicker in the past make 18 of his top 23 kicks. So we can see that the probability that the kicker win is 18 over 23, right? Because he kicked, he got the goals 18 times over 23 times. So the probabilities of these players or the amount of money is the same, right? It's 18 over 23. Okay. If the player kick the goal, so he will get the amount of money. Okay. So is it clear in this case, right? Okay. And okay, because he get the 18 times to get a goal, so this means that he will got five times to miss a goal, right? So the probability here is 5 over 22, right? So we finish the table for this, right? And the expected value here is, okay, you use the same formula for this. You use this guy times the probability, corresponding probability, plus this guy times this probability. And the final result here is, okay, the final result here is 14.78. Okay, that means that the expected value can guess the future, can predict the future. That means if this guy play this game a long time, or for a long time, so he will get the average money is this number. He will get he win and he will lose, he win loss, something like that. But the average result he get is this number, this kind of money. Okay, that's either the expected value can predict the future, something like this. Not exactly, but can approximately. Okay. Any question so far about this? Clear, right? Okay, so that's either the example, and we go to the final example here. The final example, okay. Final example for today. Peyton is trying to decide between two different investment opportunities, and two plans are summarized in the table. Okay, I will give you the table. Okay, the left column give the potential earning, and the right column give their respective probabilities. What should we choose? Okay, so we have two plans here. The plan A, okay. So he invests the money to plan A, right? So the earning money he will get is he will get $1,200 with the probability here is 0.1, and he get this amount of money with the probability is 0.2. Okay, and here he will lose the money because it's negative, right? When we invest money, so we will win or we will lose. Okay, so win will be positive, loss will be negative. Okay, so he will get the negative 575 with the probability is 0.1. That means he has the 10% to win, right? Or 10% to loss. Okay, and he had 20% to loss this kind of money, this amount of money. Okay, and plan B is this guy, plan B here, and plan A here, and plan B here. So the question here is, with the plan he should choose. Okay, with the plan he should choose. So to do that, we need to calculate the expected value of plan A and expected value of plan B, and we compare together, right? If the expected value is higher than the expected value in another one, so we will choose this plan, right? Because when we invest in a long term, so we can say that we can expect the value like this. Okay, so if you calculate the expected value is higher, so we will should choose this plan. Okay, this is the idea. You got the idea, right? Okay, so now you will calculate the expected value for each plan. Okay, first. So apply these formulas. Apply the formula. So you can calculate the expected value for plan A. Okay, I will calculate for you. See, you can see. The disadvantages when I show you the slide is very immediately. Okay, you cannot see the step by step, right? When you look at the slide, it's a boom. So that maybe you will not understand, but I will write down here so you will see the step by step, right? The probabilities of the plan A, I write A here. Okay, so you see that. Okay, use this value to probability. It's 1,200 times 0.1, so it's like this, and plus 900. Okay, this guy times this guy, and plus this guy times this guy, the corresponding probability, and plus this guy times this guy, and plus this guy times this guy. So after that, you will get the result here, right? So you can see the expected value in the future. It's maybe this guy. So that means that you will expect the amount of money in the future is 24.5 approximately. Okay. Okay, that is the expected value for A, plan A. And the second one, we need to calculate expected value for the plan B, right? As you do the same similar thing, right? Okay. You use this guy times this guy plus this guy times this guy plus this guy times this guy, something like this. After that, okay. So this is 1,500 times to this guy plus 800 times to this guy plus times to this guy. This guy. And plus to the final one times to this guy. And the result you will get here is, okay, I calculate at home, is number. So now that means that in the future, when you invest a long time, you will get this money. Okay, it will be loss and win, loss and win, loss and win, but in the long time, maybe you will get the result approximately. And for a long time, you will get this the result. Expected value is just used for release the future. It's not exactly, remember that, it's not correctly all the case, but it's just approximately. So now you can guess that if you invest to this plan, it is better than invest to this plan. So now you choose plan B is better. Okay. Any questions so far about this? Clear, right? Everything clear, right? Okay. Okay, so I think we finished today. Thank you for your attention. I make attendance already? No? Okay, so stay here. I will make attendance. Samia,
Here.
okay. Max, okay, you here. Connor here. Laurel, okay. Xavier coming, okay. Haley, not here. Bob Jim. Christopher Dollars. Christopher not here. Jay Ely not here. Mackenzie, Mackenzie here. Robin here. Robin Bennett. Bennett Crosby. Okay. Abdul Hamid. Abdul Hamid, let me know already. Okay. John Peters. Kathleen.
Here.
Okay. Lip. Okay, not Lip, not here. James here. Trevor, not here. Delaney. Okay, bye bye. Delaney, not here. Cordelia, Madeline here. Cordelia, not here. Alondra.
Here.
Okay, let me see. Matu, not here. Rick. Okay. Tyler, not here. Aliyah Smith. Okay, I see. Yossi not here. Sullivan. Maria, okay, here. Thomas, not here. Priya, Wally,
Here.
okay. Carl Waller here. Arthur, not here. Tyler, not here. Okay, thank you for your time.
Thank you.
Okay, goodbye. Have a good day.